My name's Roger Pennington. I'm with Blackmore and Glunt. We're the Fulton dealer. Our Cincinnati office phone number, where I'm out of, is 513-489-5225. We're here today to talk about the Fulton Endura boilers, and these are 2 million BTUs. There's a nameplate on the back, it's a little black nameplate about yay big. Gives you all the information on the boiler. Most importantly, it gives you the national board number. If and when you need to call for parts, you'll have to give them that number because that identifies this individual piece of equipment. We'll start off here with at the beginning of the boiler. This is boiler number 1. We have our on-off button. This will shut this boiler down when it's not lit. And at the top, we have boiler control. That brings up this status menu. And the very first one top left, that's our boiler status. That lets you know kind of a brief overview of what's happening. Right now, it says that the limit string is open, and that is because of this button here. Now we switch to standby. So we'll go ahead and leave that off because I don't want them to run while we're videoing because we'll have all the extra noise with the cabinet doors open. So this gives you the firing rate, the flame signal, the position of the air fuel actuators, your temperatures in, out, combustion. Gives you your set point that you're receiving from the building automation system. It is a 0 to 10 volt signal, and right now it's asking for a 153 degree set point. If the boiler's running, you'll have a delta T down here, so you'll know what the difference is on your inlet outlet. We'll go back one screen. We have a safety device status. All dots there, all those circles, they have to have a green indicator in them, otherwise the boiler will not run. Right now we have one off on the left column, one off on the right. The one on the left says the on-off switch is not made. That's an easy enough one to take care of. The one on the right says the BMS interlock is open. So at the moment, the BMS system is preventing this boiler from running. Now we can override that for various reasons. Maybe the BMS system's being worked on and you need some heat in the meantime. If that is the case, we can come down here to the admin menu. And over here on the right, we have BMS network status. We can go in there. This is BMS control. When that is green, the boiler is taking its enable signal from the BMS system. If you need to override that, you can tap that, it'll go to yellow. And now when we go back here to our safety device, we see that our interlock is now made. So we can run this without the BMS system actually calling for it. Should the BMS be totally down and we're not receiving a set point from them, we'll go set point here. We have a manual set point right here. I'll be going over all these other screens as we go along. So right now, this is a 160 degree manual set point. Let that shut off. So it won't, at that time, we wouldn't get the 0 to 10, so to default back to its manual setting. And operator control. If we want to manually operate this boiler, say at a specific firing rate, we have several green boxes. The first one over here we'll talk about, that's our anti-short cycle. Right now that is enabled, and it's enabled for 1 minute. So after the boiler shuts down, it will not be able to refire for at least this time frame. So for the moment, we're going to go ahead and disable that. On the left, we have the boiler enabled and automatic control. If we want to take the boiler offline completely, we can take that, put it to disabled, and this boiler will not run. And that does not matter what position anything else is in. If that is turned red, she's offline. The other thing we have here is automatic control, and we can put that to manual, and we'll go ahead and enable that. So once the boiler is enabled and we're in manual, then we can tell it a firing rate. So we'll click that, we'll just go to 7. 7 is our minimum firing rate, 7%. And then if we hit start, manual start here, we'll actually put a call for heat in, and the boiler, provided all the safeties are made, the boiler will start up. And up here in the top here, oh, I keep hitting that I, it tells you what it's currently doing. So right now the fan motor is coming on, and the beginning of that is real quiet, even with the cabinet doors open. As it ramps up, it becomes quite noisy with the cabinet out. That is a massive blower in there. It's also a high pressure blower. So you can hear it, the damper's opening. So that's gonna go through the normal startup. We hit manual stop, and that will cause it to go through an ordered shutdown. And that's how you can manually control this. When you're all done, it's extremely important to put this back in automatic and re-enable the anti-cycle. So everything should be green when you're done. We also have our hysteresis setting here. So we've got a 5-degree start and we have a 5-degree stop. So if we have a set point of 150, our boiler will start 5 degrees less. So at 145, we're gonna modulate right there at that 150 point. And if our load dropped to the point that even running at minimum fire, we're gonna start to increase temperature. When we get up to 155, we're gonna shut down. So we're gonna try to modulate at that 150, but if it's still too much, you just shut down when it gets to 155. And then after the building loop cools down, we'll restart at 145 again. So that's those hysteresis settings in there. Back, we have a boiler history screen, and this gives you an idea of the efficiencies it's been running at. It also gives you information as how many hours has it been running in a certain range. And the ranges are 0 to 25, 25 to 50, 50 to 75, and then 75 to 100. And it will tell you how many hours it's been in those areas. And that gives you a pretty good idea of the size of the equipment versus the load out there. If we have most of our hours down at 0 to 25 and we have none at 75 to 100, that boiler's probably a little big for the current load. As it is, we've got 527 hours at 0 to 25, 528 at 25 to 50, 149 at 50 to 75, and we got 60 at 75 to 100. So that's actually a pretty good distribution of the firing ranges here. So it's not really running too low or too high. On the far right, we've got the boiler online hours. So that's the time that the boiler has been powered up. We've got the boiler run hours. So that is when it's firing. And then we have the cycles. Currently we have 754 cycles. So we've got roughly 1,100 hours to 750 cycles. So each cycle is on average lasting a little over an hour. That's great. When you can see that, when the boiler comes on and it runs for a good period and then shuts off, you're gonna get the best life out of the equipment. We'll go back one. The next screen is your alarm history. And this will give you, I believe, the last 25 alarms that have occurred. And we can scroll up and down through here, and I think, yeah. So we have, various things that we'll see in here. It gives you the time, the date, when that occurred. For example, actually, I think it's 50 alarms on this. So on number 40, we had a PLC limit trip, and it was HLTC, so it was our high limit temperature control. So we had a high limit event on this, and that occurred on September 21st. They were probably doing the startup at that time and checking all the safeties. After you highlight one of these alarms, you can view alarm info, and it will give you additional information about that event, what a possible solution may be, and it goes into detail what that actually means. Any questions so far? If there are, and I'm going through this, just speak up and we'll do it. On this screen, we also have a reset low water button. I'll show you how we get to the testing of the low water here shortly. On lead lag, these boilers are not configured for lead lag. At least the internal is not configured for lead lag. They have the capability of talking to one another. That evidently is not the way the system has been set up. I believe lead lag is being controlled by the building automation system. Next screen down is our PID control. We have a local PID, and we don't have actual numerical values here. It's more of a slider that allows you to adjust it. We have a cold start setting. It's not enabled. Basically what that says is if your loop temperature was, say, 50 degrees and it comes on, do you want it to start up slowly? Is there something out in the system that you can't just bring it up? If there was, then you could enable that to control that startup. We have a low fire hold. That's not enabled either. Sometimes we may have a system, actually frequently, the boiler gets put in, but there's more than one phase to the building, and we may only have the first part of the entire project installed, and they need heat. Well, if we were to just allow the boiler to come on and just run, what would happen is it would probably come up the temperature too quickly and then shut down, and we'd have short cycling. Low fire hold will tell it after you light, ramp down the low fire and stay there for a period of time. And that time frame is adjustable, and that way we don't immediately satisfy our loop temperature and go off. We have freeze protection. We're not using it on here, but if we had boiler pumps on this, we could bring the pumps on, and if the boiler temperature got down to 45, we'd start the pumps up. If it continued to drop, we'd actually fire the boiler at minimum fire, but that's not being used. And we have outlet monitoring, and what this is if we reach 185 degree outlet temperature, then we are going to drop the boiler firing rate back down, because our ultimate limit is 200 degrees and we don't want to exceed that. So if we get that close to it, we're just gonna back it off, let it run for a bit, and then when it gets back down to 180, we'll release it and let it go again. And that just helps to prevent any nuisance trips. I don't think your set point actually goes up near that high. Does anybody know what the actual range is on this? On the 0 to 10? Okay, I'll find it. Set point, that's our next one. So on the BMS portion of it, here we go. So right now, we have on the 0 to 10 volt signal, we're actually receiving a 5.5 volt signal from the building automation. And here is that range, by the way. At 0 volt from the building automation, we have a set point of 120. At 10 volts, we have a set point of 180. So that's our range in there. And over on the right-hand side, it tells you our current set point is 153, our minimum is 120, our maximum is 180. And on the set point configuration screen, we've selected the BMS analog 0 to 10. Outdoor air cutoff is currently disabled. We don't have an outdoor sensor. So that won't come into play. And actually, I am going to set those values at an extremely high range. So if it ever did get enabled accidentally, it's still not going to do anything. So basically, if it reaches 200 degrees outside, your boiler's going to shut off, but I think you're going to have other issues at that time. So here's our manual set point. So if we lose our building automation, we're going to run at 160. And over here is our minimum and maximum set points that we can set it to. Scheduling is not in use. It's extremely rare that anybody uses it. We do have some trending screens. They are not the most useful, but they can give you some rough information. You can tap this screen. Right now it's showing your inlet temperature. And if we tap it, it can cycle through, okay, I moved it. We can cycle through the different lines and it will tell you what that graph is. At the bottom, it gives you your times. And so our O2, we have an O2 sensor on here that we monitor. Do we have an O2 on this? Yeah. So we actually monitor the O2 in the burner chamber, and we do that for trim. So when we're operating in the summertime, we'll actually change our air-fuel ratio. We'll actually bring in more air. Well, technically, we actually reduce fuel, and I'll show you how we do that. And that's so in the summertime, we have more oxygen content per cubic foot of air. So to maintain the same O2 as during the winter, we'll actually have to trim those values to make them work the same. Now, the advantage of that is if you've ever worked on a boiler that does not have O2 trim, then if you calibrate it in the summertime, it works great in the summertime, but when it comes around the wintertime, well, now it's running too lean because it didn't self-adjust. And vice versa, if you calibrated that type of a system in the wintertime, in the summertime, it's going to be way too rich. And we'll go back. We have an admin screen down at the bottom. Top left, this is our time. Let's make sure that's correct. We got 11:25 on that. And 11:33, it's pretty close, but we'll go ahead and set it. And that's a simple matter, just tap it and set it like that, and you're good. We have an Ethernet address. This is currently set for 192.168.1.100, and it is not being used. I spoke earlier about having them operate in a lead lag configuration. In order to do that, they would have to have that network cable run between them. But since that's being done by the building automation, there's no need for that to happen. Over on the right, we got a little symbol of a battery, and right now it says battery okay. There is a little backup battery on this back of this display. It lasts for about 5 to 7 years. So this indicator would be one of the things you would keep an eye on your annual maintenance. And if it starts to go down, it's time to change that battery in there. And that's a CR2450 battery. And like I said, it's on the back side of the display here, and I'll show you where that is. We have the eye, that's just the information. Really doesn't tell you a whole lot. Our green triangle says everything is okay. If it's flashing red, that means we have a current active alarm. We can press that, and that will take us to the alarm history screen, and it would tell you what tripped that at that time. Go back, and we have a symbol of a little wrench here. And when you do a maintenance, you can fill out in here and keep a history on the boiler as far as what's been done over a period of time. Before I leave here, I'll actually put in here that we've done a training today. And over on the right, we have a symbol of a lock. It's currently unlocked. On this boiler, we have the ability under user configuration, we can put a password here and lock out parts of this menu. So if you have an issue with somehow or another items becoming changed over time, if you need it to lock the system, that is a way to do that. And you don't have to lock everything. If you want to only lock out the set point control, you put that in there, and then in order to change the set point, you would have to put this password in here. And you pick the password. It's not something that we would have. So if you ever do put a password in there, make sure it's recorded somewhere. To recover from that, if you lost that password, the only way to get back into that section would be to basically start over and reload the firmware, put it back to default, and then re-enter all the data. So we don't have access to that either, so that's a good thing to record somewhere. Over here on auxiliary, we tell the controller what we have enabled on this. The screensaver is enabled, and it will engage at 10 minutes after the last keystroke. If we had an isolation valve or a boiler pump, that would be one of these two options. We name the boiler here, and we tell it whether or not we're going to be lead lag. Do we have an alarm horn? Some locations actually have a horn outside that they want activated, and whether or not they have a secondary low water control, or if the system has a domestic heat exchanger on it. Universal data, that is one of the simplest ones I've ever seen. This is telling me basically the set point is being provided by the building automation system, and that's all that's being done externally. So on local network provider, that is anything physically connected to this boiler. So we have a set point that's connected from the building automation. If they were tied together, we could send a set point to one boiler and use it on another by coming down here to the boiler network receiver. So we could actually send that data across that network as well. And we could do the same thing with the BMS enable and everything else. And then if the BMS network provider was going to write a set point over the either BACnet or Modbus, then that would be this middle selection. But on this one, we just have one, and that's at 0 to 10 set point. And boiler network status is not really going to give you a lot of information because that is on that data link and that's not being used. BMS network, that's where we override it, the enable signal. So we'll put that back on. And down here at the bottom, we have our system diagnostics. We have our control diagnostics. And this gives you the information that's happening right now. Tells you where the set point's coming from. Are we in a normal modulation scheme? Our PIDs, is it a local PID? Is it a lead lag PID? So it just gives you a status update of what's happening. The CFH diagnostics, that's call for heat. On that one, on the right column, all the indicators must be green. On the left column, at least one indicator must be green in order for it to call for heat. So right now we have two of them that's red. One of them is the power switch that takes care of that. The other one is the BMS enable. So as soon as the BMS system enables the boiler, then it would be able to run. We have lead lag diagnostics, but that's not being used. We have a couple buttons down here at the bottom. We have File Manager and Take a System Snapshot. You can take a snapshot, and what it's doing right now is there is an SD card in there, and it is taking all the values that are currently in the system, and it's writing them to a file. So if there was an issue and you needed factory support or whatever, you could create this snapshot, send that up to them, and that would give them an inside look to what's actually happening. And we have a tech login. There is a password on that. That is used to do the calibration. When calibrating this, it has a Siemens LMV3, which is this module down here at the bottom. That's what's controlling the burner cycle. In order to adjust that, you have to enter that password, and I cannot give you that password. You do have to take the training. It's online for the boiler in order to get that password. They don't want just anybody getting in there and making adjustments. There are 10 points in the firing curve that have to be calibrated. In those 10 points, there is probably about 12, 15 different values. So it may be 150 individual values that you have to go through to calibrate the boiler. Now the good thing is, it doesn't change much. Once it's been set up, come around a year, it should be pretty close to exactly what it was already. So when you do the calibration, what you're controlling is the actuators, and we actually control these by tenths of a degree. So we may open it by a tenth, close it by a tenth, and like I said, generally it's going to be very small that you'll have to make any changes to that. Well, we got the door open. So this is our PLC. There's actually 4 parts here. We have our screen, what's called the HMI, human machine interface. I didn't pick it. Over here on the left, we have an I/O module, and that's also the CPU. We have another I/O module here, and then we have an extender that takes this bus here, converts it, sends it over this cable down to here where we continue on with the other modules. So we have just basically, there's just more I/O modules, inputs and outputs down here for the various parts of the boiler. There is, so your power comes in on here. There is a USB port over here on this side, it's actually right here. That file that I spoke of that you generate, in order to retrieve it from the system, you'll put a flash drive into that number 1 spot, and it would be just like that. So you put that in there, and then you go into that menu and tell it to copy it from the system over to the flash drive. The flash drive is listed as a DOK. Took a long time for me to find out what that actually was, but that's a disk on key. That's somebody's idea of a flash drive. So you remove that. There's also the SD card that I spoke of. That is right above that, and that's located right here. That is a high performance SD drive. It is rare that that would ever go bad, but they can. And it's relatively small. I think it might be an 8 or 16 gig. It doesn't actually hold a lot of data. We have, if we do a firmware update, we take that firmware, we put it on a flash drive, we plug the flash drive into that port 1, and then on the front there, we actually log into a hidden section, and we tell it to update the firmware. And if this was being controlled by lead lag that's built in, we'd have a network cable plugged in here, so that's how they would communicate. And then down here in our control cabinet, in the upper left, we have our incoming power. We have 2 fuses. The yellow cube fuse, that's a 25 amp fuse. That is for the blower. And we have a CC style fuse, and that I believe is an 8 amp fuse, and that's for the control cabinet itself. Our customer connections are here. So we have like the BMS enable, looks like we have an alarm signal. We have our 0 to 10 volt signal in here. They have, looks like this would be an enable relay, and that's all. It's actually connected external to the boiler. Everything else is for the internals of the boiler. Everything is labeled. It's either actually on the device itself, or it's actually labeled in the back on the tub itself. So when you're looking at the drawings, you'll be able to see what's what in here. We have 24 volt power supply. That's for basically the PLC section of it. We have a low water relay. If the light is on, then the low water probe is sensing water. If the light goes out, your probe may be dirty, or you may not have any water in the system. So you would check that. If you do, if the light does go out, you'll get a low water alarm on the panel, and we'll do that before we're done. We have an unpopulated socket right below this. Some jurisdictions require a secondary low water cutoff. If that was the case, in order to activate it, all we have to do is get a second relay, put in there, and the wiring and everything else is already done. There's another port on the back of the piping for the probe. So all you gotta do is install the probe, connect the wire that's already there, and remove a jumper, and it's online then. So they're real easy to add if you ever need to. And we have just more of the field wiring down here toward the bottom. This is our 120 volt portion of the control. And then we have relays for various objects. If we had the pumps or the valves, I know that would be these. And then some of these other ones control the blower and everything else. So this is the Siemens LMB3 that's your controller for your burner. This module here with the blinking light, that converts the output of this to a Modbus signal, and then we can take that to either directly to the building automation system, or we can put that into a protonode, convert it to BACnet, and then send BACnet out. Up above that, we have our low voltage, our 24 volt power, and then the individual I/O modules. If possible, have them label this relay that's been added as to its function, and then that way you won't get blindsided one night and if something's wrong and you need to find out what's going on. It's kind of nice to know what those little changes are. All right, that's it inside the cabinet. On this side, the temperature control with the little red button, that is your high limit temperature control. Its maximum setting is 200 degrees, and that's what it's currently at. The one under it is the operating control, and it's typically set 5 degrees below. While it is an operating control, it is not the operating control that is controlling the system. It is in the circuit, but we actually do our temperature control from the PLC. But if something happened, and let's just say it locked on and it was trying to fire all the time, this would prevent that from happening, because like I said, it is in the circuit, but we normally do it all from over there. If this, for some reason or another, didn't shut it down, that's where the manual reset high limit control would come in. So there's a lot of safeties in here to protect you, the building, and the equipment. So on a call for heat, our gas comes in over here in the top. It goes through our SKP valve. This is our regulator. The regulator adjustment, there's a screw underneath here. We have a low pressure cutoff on top. We have a high pressure cutoff on the bottom. These are manual reset. There's a little tiny black button that will pop out. Should they need to be reset, you just push them back in. So on a call for heat, our blower will come on. Our damper will open. Different models, different locations. That's why it takes me a second sometimes. So here's your air damper down here at the bottom. So the damper will go to about a 60% open position. We will complete a minimum of 2 air exchanges of the heat exchanger. So, and we do that over a period of 30 seconds. And we have a blower proving switch. So this makes sure that even though the motor may be running and we get feedback, we want to make sure that we're actually generating pressure as well. So that's what this job is. And then we have our inlet temperature sensor here. At this T connection, we have this little blue plug, and that can be removed. And this is where we measure our manifold pressure. And our incoming gas pressure is here. Our what's called main valve downstream pressure is here. And we have on the top of the heat exchanger, there is, you've got your igniter, that's this part with the high voltage lead. We have our sight glass, and we also have a window in the top of the cabinet. So you do not have to open the cabinet at all to actually see the flame, whether or not it's on. You can view it right through the cabinet. We have our operating limit and our high limit wells here in capillary tubes. we've got our ignition transformer up here on the top, and we have on the hot water outlet, we have our first low water probe. That's this one here, and there's actually a fitting up here for a second probe should one be required. This control, or this sensor here, is your high limit sensor of the PLC. That's in addition to the high limit over here. Down here we have two sensors. One of them is our stack temperature. That's this one here on the toward the center of the boiler. And we have a tube, a flexible tube here. We have a located right here on the back left side of the boiler. There's a small black device with a port on it. That is a blocked vent switch. That's set for 2 inches water column pressure. If the venting was to be plugged, this switch here would be the one that would capture that. And that's just connected over this flexible hose that comes through the cabinet here. On the blower, there are 2 connectors. And which one will give you a better shot of this right here? This one or that one? Either way? Okay. On the top of the blower, we have a 5-position plug with a red, black, and a green and white wire. The center pin is not used. This is the speed connection to this blower. It controls the speed it operates at, and it's actually a tachometer feedback, so that's how we get the RPM of this blower as well. The bottom connector is your 120 volt power. So it takes both of these in order to operate this blower. Do not unplug or reinsert this connector, the power connector, on this blower with power on. This is an ECM motor. There's some large capacitors in there. If you plug that connector in with power on, you're going to get a pretty heavy spark, and you will damage the connectors in doing so. So that connector down here should never be unplugged or reinserted with power on. The one on the top controls the speed, and if you were to unplug it, it will take off and ramp up to 100%. And that's kind of a quick and dirty way of knowing, is the blower okay? If you were having an issue that you thought the boiler is trying to run the blower, but it wasn't, if you pop that connector out real quick, if it takes off, well, you know the blower itself is okay, so that issue would be probably somewhere else. We have our blower pressure fitting here on the side of this transition. And that's it on all the connectors. On the actual back side of the boiler, we have our gas shutoff valve. And you'll notice we have a test port on the inlet side of the gas valve. A lot of people think that's on the wrong side. It's on the inlet side because we need to know what that pressure is before we open that valve. So that's how we can verify that the pressure coming in meets our nameplate rating. Our low voltage or high voltage come in through here. We have our relief valve here and a relief discharge line here. There is a temperature and pressure gauge there. And where are the electrical disconnects? That I do not know. No, 120 volt power. Okay, okay. Are they labeled as far as which one's which? Looks like it. All right. Yeah, so the 120 volt disconnects there. The e-stops are by your exit doors.
And they
doors.
still control all of that disconnect.
Okay, okay. Any questions on any of that so far?
What's controlling your speed, your blower?
That's the PLC.
The PLC does it.
Yes, the PLC sends a signal. Technically, it's the LMV3 because it's controlling your air-fuel ratios. So the signal that actually runs it and the tachometer feedback, that's actually going to the LMV3.
There's nothing in between the PLC and that motor.
No, no, the PLC talks to the LMV3. The LMV3 talks to the blower motor, the actuators, the gas valve. So that's the job of the LMV3. Any other questions on any of it? And do we need to go over the calibration process?
Well, we have to have that code to do the calibration.
Yeah, and in addition,
So it wouldn't be no good to do it.
there is an AZL2 control module that you will require in order to do that.
If we don't have the code, we can't do it anyway.
I would assume at one point you will get that code. I can't give it out right now, but I can't see that not happening.
I mean, in my mind, if we do it, we'll obviously get it, but when we get the code, we have to do it.
Yeah, typically it's a year from now before you'll need to do it. When you do get the controller to do that with, well, the training that you go through online, it explains it. And it's actually explained really well in the manual itself. I think that password's in the manual. Do you have the manual? Yep. I got one. Now there may be a second one, but yeah, second manual. By the way, in this manual, in chapter 4, it goes over all of the maintenance procedures, and there are items that need to be done on a weekly basis, a monthly basis, semi-annual, and the time frame and what needs to be done is all in here. I do suggest everybody go through this. Do not forget your lockout, tagout procedures. Okay, yeah, this section here, they're actually showing, this is the screen on the LMV control. So this is what you would see when you're actually doing that calibration. And, yep, the password's right there.
It's already in there.
Yeah, yep. That's one password. That's the password for the LMV3. You still need the password to get into the admin section to put it into a calibration mode. So you'll still need the other password as well. I don't believe that's here, but you can always talk to your sales engineer in our office and see what that process is to get that. Okay. We don't have many facility people that actually do it. Most of the time it's done by a third party. Well, a lot of times they just don't have manpower. They're stretched pretty thin generally. But yeah, we can get all that for you. That should not be an issue at all. Header sensors. it appears that we have, do we have an external header sensor that's tied in?
It's over here.
It's over here.
You're talking about individual or for the whole solution?
Both actually.
All right. Here's your one over here. Your white
Okay,
line coming
yep.
down, and then the other one is one on
Is one
the boiler right here.
Okay.
Right here.
Okay. All right. Okay, yeah. Condensate trap and neutralizers. This is your condensate trap. The boiler, when our return temperature coming into the boiler is over 140 degrees, we will no longer condense the flue gases. So we won't generate any condensate with a return temp of 140 or higher. And then the purpose of this trap is to seal off the end of this pipe to prevent blowing flue gases into the boiler room. There is a stainless steel float in here, and if there is no water in this container, then it drops down and it will seal the outlet of this trap. So here is that, and also in the bottom there is a high temperature gasket with little holes. So when it doesn't have any water, like I said, it just sits there and it closes that off. On the, I just dropped one. On your condensate neutralizer, you have these little pellets. It's a magnesium, yada, yada, yada thing. They generally will need to be replaced on a yearly basis as well. If you don't want to completely replace them, I know I have some locations that will have a pH meter and they'll just monitor the output of it. And when that starts to rise, then they'll replace it then.
How about the gasket is yearly too?
And here, it's permanent.
Oh, the last
Yeah.
brown.
I don't think I can get it out there. My hands are way too big now. It's just like a high temperature gasket. And the temperature coming into here is typically no more than about 100, 105, 110 probably about the most.
I didn't know if it would deteriorate and have to be replaced.
I have, oh, perfect. I have never seen one actually get to that point. So it's a woven, like a cloth woven saturated material. Yeah, it's about a little over 1/8 maybe thickness. So it would be rare, because I mean it's just typically just sitting in there.
Is galvanized pipe and fittings rated for that acidic condensate? Or?
I believe it is. I will double check for you. I know PVC is not. CPVC is. Stainless is. And I'm pretty sure galvanized is. Different boiler manufacturers have different requirements. And we handle multiple manufacturers as well. So let's just make sure. So you use CPVC, stainless, or galvanized. So yes, it is. The pH of the condensate coming out of the boiler is probably a little over 3, so it's fairly acidic. It's not going to melt your hand off, but if you do get it on you, wash it off promptly. That goes through the neutralizer. When it comes out, it's closer to a value of 7, between 6 and 7 in that area. And that way you can run it down through the old metal drains without cutting a groove through the bottom of it. Also, your sewer departments typically do not like acid being sent down drains because that can interfere with their process. So each boiler has a factory test fire sheet, and that is located in this envelope along with the wiring diagrams. So this tells you how everything's interconnected, and then this sheet tells you how it left the factory. And down here at the bottom of this sheet, that is all the numbers that you'll end up getting when you do a calibration. So, like I said, there are 10 points across the firing range, and then what is it? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. There are 15 data points per position. So that's 150 data points during a calibration. When you use the test fire sheet, make sure that the national board number that's on the sheet matches the boiler, because sometimes paperwork gets moved around, so you want to make sure you have the right sheet. These are both identical boiler model numbers, but the way they are actually calibrated is individual, so there may be minor differences between the two sheets. That's why you want to make sure that you have the proper one. So the way that this gets done, and we'll need to stand to just this side so he can video it. You'll have an AZL control. This is a Siemens part. Now it doesn't come with this cable, it actually comes with a different cable. Some of the boilers I work on, the LMV3 is 15 feet away, and they only give you a 6-foot cable. So this will plug in here in the top right corner, just like a little phone jack. And then that will light up. And it says off gas 0, all right? And in order to log in, we push and hold the F and the A together, and it says code. And the code's in that book, and it's 5 zeros. So we'll hit plus. So we got a 0, enter it, and we move over. 0, enter, 0, enter, 0, enter, 0, enter. So that was 5 of them. Hit enter one more time. Now we're in parameter group 400. That's the air fuel curve, okay? So, as long as the boiler was enabled, I could tell it to run. So right now we're in phase 22, and we have a countdown timer, all right? So there I have a list of all the different phases that it goes through, and it's just the different checks that it's doing. One of the big ones is phase 30. That's where it's checking the blower. And like I said, it'd just go through all of them. You have these little dashes. So right now there's a little dash underneath that sign, that's a blower. We have a dash above the up. So that actuator is opening right now. We have a 30-second countdown. So right now we're just doing our pre-purge. So we've gone through the pre-purge, now we're advancing through the startup process. So now our ignition transformer is on, our gas valve is opening, we have a flame detected, we're proving All right, now we're at P1, that's position 1. So on your test fire sheet, you have P1. So here's those values for that. Now to do a full calibration, we actually, at P1, we check one thing, and actually no, we don't, not on this model. On this model, we have to go all the way up to P9. Strike that. We do have one setting at P1. On this, we have a manifold gas that will have set typically for negative 1.5 inches. Once that's set, it never needs to be set again that I've ever run into. So then we'll go up to P9, and to do that, so right now it's flashing P1. That tells you that we are at P1. If I press the plus button, we go to P2. Now P2's not flashing yet, so it's in the middle of driving there, but it hasn't made it yet. When it starts to flash, that's when you're actually at that position. So we'll go all the way up P9. So there's P9. And you'll hear it ramp up. So we have 44.3 and 90.0. The 44.3, that is our fuel actuator, how far open it is. And it may or may not match this value. This is what it was at the factory. Once it's on site, we have to account for site conditions. So that's why you may have some small variances. If you ever get to the point to where, let's say you had to replace something and the boiler won't light off for you, if you return everything back to these values, it will light. You'll have to calibrate it after that, but it will light with these values. So P9 is flashing. So at this point here, we are looking on our O2. We want 5.6 to 5.7 O2 at P9. So since our air is already open fully on this, we'll basically have to adjust the fuel on it to make that 5.6. And to adjust it, you would to adjust fuel, you'll push the F, and you'll notice that 44.3 now blinks. So at this point, we can go up or down with that opening. When you let go, if you needed to, you could adjust the air same way. And then if you hold the F and the A together, that is our VSD, how fast our blower's running. So we got 3 items that we adjust from here. Once you got your O2 value where it is, where it needs to be, you'll drop down 1, you go to P8, you do the same thing again, then you go down P7, P6, all the way back down. So we'll go down to P1. When we're doing it with this control, you may occasionally hear a little bit of a harmonic out of this. That's simply because we're making such a massive change really quickly. So you may pass through a sound like that, but once it gets where it's going, that should quiet down. So once P1 is actually flashing, we know we're there. And then we're going to go to P0. So P1 is minimum fire. It's amazing how quiet these things get. All right, so we're blinking now, and you'll notice 11.1 and 24.1, that's these values here. There's your flame signal. To check the flame signal on this, push and hold that. And parameter 954, that's your flame signal, 100%. All right, so from here we're going to go to P0. P0 is, I'll explain that one in a second. P0 is your light off, and that's between about position 2 and position 3. So we're almost lighting off at about 30%. So that's why it's got to go back up a bit. So when we light here, we drop down to minimum, and then we go up from there. So after P0 starts to flash, that's when we would make any changes. All right, so now we're flashing. So if we made any changes, that would be the end of it. So you start all up there at 10, make sure your O2 value is good, make sure you don't exceed any of these other values, especially the manifold. So the O2 is important, your manifold's important, your manifold gas, that's really the main ones you're looking for. You're going to control your O2, and you're going to make sure everything else is in range. On the training video that they have, they go through all of it, and it's an awesome video.
That's the Fulton.
It's on Fulton's site. Yeah.
How do I get my hands on it before you
You. Yep, and you do have to have that. Now, they also have software, which I prefer, that I can plug my computer in and do the same thing and a lot more. Yes, so this is our air fuel curve right here. Using the software, it gives you a visual graph so you can see exactly. And it's typically a pretty smooth parallel set of lines. And if you get something that's out of whack, you can miss it this way, but you'll spot it real quick using the software. The software is free, but the cable is extremely expensive. It's a special interface cable that comes from Siemens, and yeah, it's outrageous for what it is. But there's no other way around it. You got to have it if you use their software. The software is called ACS 410. That's the name of the software. This is an AZL 23. All right. And there's a phone cable that comes with it, 6 feet long, and then there's a little 6-inch adapter that's also used. Personally, I make my own. The adapter, the only thing the adapter is doing is rolling over the cable. So position 1 on here is actually position 4 down there, and vice versa. If you take these connectors and you flip it, it's the same thing. And you don't even need that adapter cable then. Which the boiler does have the cable. It comes, no it doesn't, pardon me, because it doesn't come with the AZL. Yeah, the ones that actually have the AZL on it, that rollover cable and everything's all in there. When you're all done, to exit, you do the escape, which is just both of those together. You go back at the beginning, 400 series, and you escape again. Now we're operating at 11.5% and climbing. So you can go through this whole thing. You could also shut it down. So I just generated an alarm right there, which shows up here. So when you have the blinking red triangle, that is a lockout, and you'll notice up here it says safety lockout. So if we press this, then that will take us to the history, and you can see number 0, which is the last alarm that occurred. It's a manual locking. I get it. To reset that, just reset alarm. And then that can go back to green, and you're good to go. On the low water alarm, we go to, they've moved it on me several times. And I have to find it each time, actually. This control gets kind of a constant update. So sometimes they will move certain screens, and then I get to play, all right, where'd they put it? I think occasionally somebody probably worked for Microsoft at one time. Okay, so here it is. Under your safety device status, we have a test low water. So if you tap that, it's gonna ask you, do you really wanna do this? And you say, okay. And then what that actually is doing is the wire that goes from our low water test relay, the wire that connects that up to the probe, there's a relay contact in the series there. So this actually opens that wire, and it's a real test. It's not simulated. We're actually disconnecting that probe. So that is a lockout, and then we can do a reset. And you'll notice we have 3 limits that are lit up. That's because they're all in a series string, one after another. The one that actually caused it is the last one in the string that has the red light, and in this case, it's the primary low water. And we can hit reset low water. That resets the relay, puts everything back together. On the wiring diagram, actually, no, let me do this one. There is a version in the manual. It's a generic version. This is the one actually for your boiler. They have 9 pages, and it has every part in this boiler in here, including part numbers. So if you needed to order a specific part, there is a part number there. So you'd call up and say, hey, I need this part. They're gonna ask you for your national board number and make sure that you get the proper item. The power comes in here. You got your 2 fuses up here. Here's your low water relays. Comes down through there. Comes down through your operating limit, through your high limit. Goes through our front panel switch. And then it comes on over. And on this, and it's really hard to see, but there'll be a number here, and it says 187, I think, or something like that. But you'll have a 2, and then you just go to that line number, and you'll see where it picks it back up. So it leaves here, it comes back over here, and that's how you can follow that. Relays will let you know where the contacts actually are, because sometimes, the relays here, it's like, okay, where is that contact located? So on the line next to it, there'll be on the top, there'll be a normally open. So the normally open contacts for this particular relay are at those points. Same thing with the normally closed contacts. So you don't have to go searching everything to find out where that contact is. So this is the LMD3 portion. You've got your actuators, there and there. And the second page, this is the PLC wiring, so that goes all on that module. And then the third page will be your customer connections page. So anything that's field wired will be on these connections. And then after that, they pretty much just go through how all the individual parts and things, where, you know, if you wanted this particular module, you can know it's on this column and it's over here. So it's sometimes takes a little bit to get used to how they do it, but after you do get used to it, it's like, it makes life real easy compared to some manufacturers. So I mean, it calls everything out. As far as spare parts, I would probably make sure you have these two fuses. The cube fuse can be sometimes difficult to obtain locally, but you'll be able to get it at any supply house. But whether or not they actually have it in stock for you, yeah, that may be an issue. So that's one I would recommend you have on hand. The other relays and things, so they're made by ABB. You can order them through us if you wish, which is supposed to tell you, well, technically you'd order them through, yeah. I work with a lot of different contractors. I can't remember names. So yeah, you'd contact them first. And then, yeah, so they would be your first point of contact, and if they can't solve it or whatever, they'd call us, and we'd go from there. On testing, they go through, in the maintenance section, they go through all the process of testing. On the operating control, you just turn it down, should shut down, put it back where it was. The high limit, you turn it down, it's gonna trip. So I had to shut the boiler down also. You turn it back, hit the reset. On the low gas pressure, you can shut the incoming gas, run the boiler. It's gonna trip out on low gas. On the high gas, you will close this valve. Let's see, this way or that way. Yep, yeah. These don't get operated very much, so they can be a little tight. So on the high one, you'll turn it all the way down to its minimum value, close this valve, and then try to light the boiler. That will trip this one. Then you open the valve back, reset what it was set at, and then reset the button. On this dial, you have this little white line, that's your pointer. So the dial will rotate, and you're looking at whatever value is opposite of that little white indicating line. Underneath this brass cap is your gas adjustment. So there's a little straight blade screwdriver slot back there. This port is not a gas vent, it is an air port. So it does not need to be vented outside or anything, because it is not a gas port. On the blower proving switch, you have a test port here on top. It's a little needle valve in there. You loosen that up, take that little needle out of there, and with that out, it will trip the boiler on that. That is automatically reset, so you'll just put that back in and restart the boiler. Low water's up there. The back pressure, or the vent pressure, you'll disconnect that line from the vent connection, and you can just pressurize it with a little squeeze bump or whatever to test that. That trips at 2 inches water column. And that's about it.
What about your cables in the bottom?
Which cables?
All of them, throw those down there in the bottom, maybe 6 or something.
I have no idea.
That's the control guys, full action.
Yeah, when it's done by somebody else, it's like, I don't know, where your piping goes, I don't know. That's a disadvantage of not being here during that time.
Is that about the only thing that's field installed?
What's that?
Is that about the only thing that's field installed?
I think
The,
just the
this, yeah, that and the
relay
sensor.
And the sensor. The sensor's over there, one to the pump.
Did we supply any other equipment?
No, this is all
Just the
y'all supply.
two boilers?
Yep.
Okay.
And I think, of course, the.
Neutralizers.
Neutralizers. No, we bought all the venting and everything.
Okay. All right.
Although you did the protonode.
Okay. Where's that physically located? It's in their cabinet?
Yeah.
Okay. So from the boiler, it comes in here on Modbus, and then it leaves this in BACnet. That's what your building automation system takes. And you can also plug in a laptop there, and there's a address on the side and password, and you could actually see those values of what's on the boiler.
Everything is on the screen.
Unless there's a question, I'm done, but I'm here for any questions you have on it. You know, we should be good to go then. Once again, my name is Roger Pennington. I'm with Blackmore and Glunt, and the phone number is 513-489-5225. Got any questions in the future? If you need documentation or anything, give us a holler and we can get it right to you. Make sure you follow your lockout tagout, read the manual, understand the manual. If you don't understand something, give us a call. We can walk you through anything you need. That's it.